Okay, folks, we're back for more GIS fun here. And this week, what we're going to do is we're going to play around with table data and use two very different types of table data. I'm going to stress the differences here, try to make sure that you guys are aware of what to do and when. And in order to show that, here's the map I made. We're going to take housing growth and earthquake data in Northern California and put these things side by side. This is a very non-scientific study that we're doing. We're not doing any statistical analysis, which is what you would really want to do if you were truly looking for patterns, but it's kind of a fun, interesting thing to look at and question and just see, you know, where we have housing growth in the state. Is there kind of this, you know, inverse or negative correlation with where we've had some big earthquakes in the past? And looking at this, it wouldn't necessarily appear so. There'd be other factors at work. Really, the only reason we're doing this way is because I've got the data. It's kind of an easy thing to highlight these different types of tables. So this is your end result right here. And to create it in the data section of the file section of our Canvas page, you will see this NorCal Quakes folder. Okay, and so again, as always, hit those three dots, download, zipping all that together. I'm going to save it. You can see it's processing there. It's a little bigger than some of the previous ones. Click on that. Go here. I'm going to left click, or right click rather, and hit cut. I want to bring that into my documents. ArcGIS. Right click, paste. I'm going to right click on that to go to 7-zip, extract here, and I get my NorCal Quakes folder. And I'm also going to right click and delete it. And you may be noticing at this point too, as you're going through these, every time you download something from Canvas, it just calls it data export in this, because it's coming from that data section, I imagine, is where that data comes from. So that's why I'm right-clicking. I'm deleting these things so I don't have multiple versions of this with a 1, 2, 3 added to the end. It just helps me make sense of what we've got. And clicking in here, it did bring stuff down, and we should have two tables, which are these NorCal Quakes.dbf and the Census Housing Units Change.dbf. And a .dbf file, it's a DBase file. It's a very old database spreadsheet file format. And you can see my computer doesn't even know, I haven't told it how to read it. You can read this with either a text editor or Excel, I think, can still read all of this stuff. The reason we use it is because it is so simple. It gives as little trouble as possible to ArcGIS. When you bring in an Excel table, there are all sorts of things that can go wrong, but these very simple ones like the DBase files, those comma-separated values files or .csv, those are useful. Just the .txt are also good formats to use. And we'll see how when we bring this in, it should all look fantastic. So instead of working here, let's open up ArcMap. We're going to bring that counties shapefile in and the tables in. Bring mine to my other monitor so you guys can see it. All right, instead of going to catalog, let's go here to this add data button, and we'll go into NorCal Quakes, and we have much easier to see our county shapefile and those tables. So I'm just going to left click and drag, grab all of them and add them. And so all that's really being drawn are our California counties right here. The tables we can't actually draw. There's nothing to draw yet. It's just tabular data at this moment in time. And if I click on this list by drawing order, the tables seem to disappear, right? And so for now, we're just going to use this list by source so I can see the tables. I can actually do stuff to them from the table of contents here. And let me make sure we can see everything. So for now, let's just leave California as is, and let's first look at this earthquake data that we have. So right click on that, go to open table. Now this is just a standalone table. It's not connected to any shape files, but from the example I showed, I converted this data, these data right here into little square points. And I also did this graduating size, so the larger the magnitude, meaning the more energy that the earthquake is releasing, the bigger that square was. And so I'm going to show you how to do all of that stuff right here. And it's pretty straightforward, but there's some key things you need to keep track of. Okay, so we have a handful of fields here, these columns. Some of them may make sense, some may not. This goes back to that idea of metadata, being able to see what some of these coded things mean. But I'm just going to go through this stuff for you guys. We have date, pretty self-explanatory, and then most importantly, we have lat and lon, right? Latitude and longitude. And if we have a latitude and longitude or some other kind of coordinate pair fields in here, we're able to use that to create points to show the data, right? So the fact that it has this lat long means we can use it, we can do something with it. And just keep that in mind. We can use any data that exists out there in the world as long as they're spatial data, as long as they're tied to some geographic location in some way. So in this case, it's tied to a precise point on the globe, right? So if we have that in here, we can turn it into something that we map. It can be something visual, like we're going to do, right? So latitude and longitude, that's good. Depth, magnitude, there's a handful of stuff. We'll use this magnitude, and again, meaning the power that's released, and just so you're aware, magnitude, it comes from this moment magnitude scale. Really, the way to think about it is a magnitude of a 3 is where you might kind of question, did I just feel an earthquake? You don't necessarily notice it, or it doesn't really strike you as something. A 4 is when it starts to be more noticeable. 5 is when it starts to get scary, and then 6 is when we get into, kind of some major earthquake damage. The Northridge quake back in the 90s was a 6.4 to 6.7, depending on who you ask. Right? And the Great San Francisco earthquake back in 1906 was an 8.0, just to put this into perspective. But for now, don't worry about that. Physical geography lesson over. Let's get into this technical geography lesson here. So lat long, let's figure out how to use that. I'm going to go ahead and close our attribute table. And I'm going to now right click on NorCal Quakes. I'm going to come down here to display XY data. Okay, and left click on that. And so XY refers to some kind of coordinate system like latitude and longitude, right? This is the XY graphs that you would do in algebra classes, stuff like that. And then Z gets into three-dimensional stuff, which we don't have here. We're not going to mess with anyway. That depth one we could play with, but we're not going to. We're going to keep it simple. Now, luckily, with ArcGIS, one thing they've written in here is that it automatically, if it sees lon or longitude or something like that in the field names, it automatically puts it into the proper X or Y category, right? So lon is put into X, Y is put into lat. And if that's confusing, Sometimes the best way to do this as you're first learning it and thinking about it is look at a map or a globe or something like that. Think about longitude lines, which they're running up and down, but they're measuring over, right? They're measuring east and west. So it corresponds with that x-axis, one of our algebraic grids. Same thing with latitude and the y-axis there. So that makes sense. That's great. But we're not done. Don't hit OK yet. Because this coordinate system of input coordinates, it is imperative that you know what you're doing and know what you should be doing with this coordinate system. So with this, let's go ahead and hit edit so we can change it. And you'll see it's got some information here already placed in here. That's wrong information. I don't know why it does this, but it does it. So we're going to hit edit. Okay, and we want to actually close this projected coordinate systems and go into geographic coordinate systems. And this is the reason we're doing this, just so you know, is I'm telling you what to do here, which one we're going to be using. If you found data on your own, you'd want to look through the metadata. You'd want to get some answer as to what are the original coordinate system parameters that you're using. What's the datum that was used? Stuff like this. So this is in the North American datum of 1983. And I know that because it said so at the site from which I got the earthquake data, right? So in here, open up North America. And so if you just have a datum and it's not something like, you know, referring to Teal Albers or some of this other stuff, it's going to be in that geographic coordinate system, right? Let's see, USA and territories. Go down here to NAD 1983. You don't need to get creative here with these things. Ours is just the straight North American datum, NAD 1983. If you don't know what HARN is or these other ones, or it doesn't specifically say 2011 next to your stuff, just default to this right here, okay, to the standard one. So I'm going to hit OK, and in doing so, this will actually draw it in the proper place. Remember, going back to datums and all that, we can have a latitude and longitude coordinate pair, but if we don't know that precise origin point for those numbers, it could be in a totally wrong location, right? Off by hundreds of feet and all that. So that's why we take our time to do this. And once we've done this, now we can hit OK, and it'll think, and it places these right here. And you may think that, uh-oh, I've got these things spilling out of California. That's okay. That's good, because these are earthquakes that took place in the water. So that's not incorrect or an error. This is exactly where these things should be. Okay, so very good. And as a reward, let's hit save. Let's put this in our stuff right here. We'll call this quakes working. Okay, so I saved that. Now, another very important thing is that we have our NorCal quakes right here. We've got these points, but it says events right next to it, right? This events thing means that this doesn't actually exist. It's kind of a temporary file. So if I were to close this, if I wanted to bring these earthquakes someplace else later on, I couldn't do it because they're this temporary entity. So every single time you do this display XY data, it's very important. It's just a good habit to get into to not stop here, but instead right-click on this events thing, go down here to data and export data, and we're going to turn this into a shapefile, right? An actual real file. And so it'll be in this CalQuakes. That's a different one. That's what I was playing around earlier. Let's go here to folder connections. You may need to do this, you may not need to do this. I'm going to actually link it to documents. Oh, for crying out loud. Hold on, let me do this. Hold what you got. think it's this other documents. Yeah, in fact, let's just do that. Sorry about this. I'm horribly unprepared. I'll go in here now. Here we go. And I'll just call this earthquakes. Okay. And hit save and hit OK. And yes, I want to add it. Now you might not notice anything different. I'll change this so it's a little bigger here so we can see we've got both, right? But this earthquakes thing is real in the sense that it's a shapefile that we can send back and forth to other map documents and all that. That's what I want to use. So I'm going to right click on this events and I'm going to hit remove. So I'm not confused. And I'm going to hit save and everything is saved. And this also becomes important later on if we start to manipulate some of these points and do different analyses on them or change them in any way. You can't do that to these events files. So this is just a good practice to get into. All right, now let's get into that graduated symbol idea where we can change the sizes here. All right, so let's right click on earthquakes, go to properties. And this is where in the symbology tab we can start to play around with stuff, right? And in quantities, we've got that it starts with graduated colors. That's not going to make much sense, right? If we use magnitude and we have these points, they're all the same size, but the color changes. It's not what you want to do with points. It's fine with this stuff when you're dealing with polygons, when you have the counties themselves. We'll do that in a little bit, but we want graduated symbols here. And let's do magnitude. And so this automatically populates it with a small point for the smallest magnitude and a larger point for the larger magnitudes. And you can see I did stuff over a 5.0 to be, significant ones. Things are actually going to start feeling here. If I hit apply, you can see we have these different sizes at work. Now, this dark red, I think it's kind of hard to see the different points and all of that, so I might want to change that color. Also, this label with the 6 decimal places is never good. Remember, right-click, format label, drop this down to 1 because that explains it so we can see it right there. Makes a lot more sense. And if I hit apply, that just updates that there. We can change the sizes right in here if you want to make it get bigger for the biggest one or smaller for the smallest one, and then it'll just adjust everything else in between there. We could also drop it down to just 4 points if you really wanted to. Don't get too creative with that because really anything less than 4 or more than 6, it's going to get hard to tell the difference between those things. So just be aware of that issue. And then if you want to change this color here or the shape, if I double click on that, let me make sure I'm not lying to you. Let's change that to yellow. No, that's not the right one. Oh, it's template over here, you dummy. In here is where we can change that color. So if I change that, then see they all turn to green. Same thing if I want a different shape, like that right there. I can do that and they change to that different shape. And you don't have to use a square. I just did it because I like it. You can use other things. Do be aware with some of this stuff, if you start to get creative with these things, press play, it can get really busy and kind of hard to make sense of what's what. And it just kind of starts to hurt your eyes, especially with some of these smaller ones, right? So typically you want to stick with this kind of stuff in here. These simple shapes do a pleasant color, nothing too wacky, but also something that does, stand out. And you're going to have a much better map than if you get something too creative. And again, if that smallest one is too small, then just change that to 6 and see if you like that, right? And kind of keep playing with that stuff. I'm just going to leave this as is for now, and I'm going to hit save. right? And with my legend, I can also put this stuff in later and just explain that these are earthquakes, this is the magnitude, so it's really easy to see. I don't have to turn on the labels, right? Because I could right-click, go to Label Features. In fact, let me right-click and go to Properties. So we don't want that MW. If we were to do the actual magnitude right here, it can get kind of confusing. There's just too much text there. We don't want that. It doesn't matter the exact magnitude. We just want to give that kind of relative magnitude for these individual earthquakes. Which ones were bigger, which ones were smaller, and so on. Hit save. Okay, so we have our earthquake stuff. Now let's play around with this housing unit, this growth. We're going to display. And I thought a way to show growth in California counties was to look at the number of housing units that are actually being built, right? So we hit open here. We have our county. We have some different years from the past. And so it's actually going in reverse order back in time. We have 2005 is the most recent stuff, 2000 and 1990, also kind of right before the housing collapse and all that. You get a picture of that record growth that's going on. So we have that stuff. We have the change between the year 2000 and 2005, which is what we're looking at here, and then that as a percent, right? And we also have this density stuff and so on. But this change percent actually can give us a sense of that growth, what's actually taking place over this 5-year period, or in other words, who's grown quickly and who really isn't, right? Like Alameda County, only 3%. You get into something like El Dorado County, 12.6. So you get a sense of different growth rates. So we have this here, but it doesn't have latitude and longitude. We can't do that display XY data, but we can do something else. We could do that joining, which we've done before. You did that with the emissions stuff. So we can do that again. We have this county field here, and we can look in counties, an attribute table, and sure enough, we have a county field right here. And as long as these are spelled the same way, say it can get confused if one of them is in all caps, the other one has lowercase letters, that you want it to be identical in order for this to work. So just be aware of that. Let's go ahead and hit close. Now we're going to join, and this is important to think about the logic of this. We're going to join this table, census housing units change, to this shapefile, counties, right? If you're adding the table to the shapefile itself, you always want to right-click on that shapefile, right? And that's where we do our joins and relates. Do not right-click here. You can right-click here and do joins and relates here, but it's not going to work. It's not actually going to do anything useful for you, right? So whenever doing this joining concept, which we'll do in the future, I'm sure, right-click on the shapefile, on the actual thing that's already there on the map, and go to joins and relates and join. From here, choose the field with the drop down. We want county. Now this has put in NorCal quakes, which we don't want. So we want to actually switch that. And again, it's one of these things where it doesn't necessarily know what you should do or shouldn't do. So you want to be paying attention to what the computer defaults to. So in that case, we needed to change this. But good news is with number 3 here, it did default to county because these things have the same name. So let's hit OK. And then again, for whatever reason, they don't give you a thumbs up or anything. You don't know if it worked or didn't work or whatever, but we could always hit this blue identify little tool thing here, click on any of these. All right, so we've got Tulare County. We scroll down and it's successful because we see this year 2005, 2000, the percent change stuff, all of that. Okay, so it actually worked. And if you're still not sure, you can click on some other things and we get the number right there, right? So it worked. And I'm going to hit save so that if it crashes, I don't have to join anything anymore. And I'm going to go right click into counties, go into properties, symbology, and quantities. And again, instead of doing that symbols, because that wouldn't make sense, we're going to use this graduated colors thing here. And value, let's do that change percent, right? And we can, again, pick any color, though pick something that is that single color progression. So it'll be lighter to darker. Will indicate, darker means more. So I'll hit apply. So we can see that the lighter the color of the counties, the less growth is taking place over this period of time. The darker the color, the more growth is occurring, right? Another thing, as always, check these labels that's really ugly. So right click, go to format labels. These, I don't know why it does this 6 decimal place stuff all the time, but drop it down to 1. That's all you ever need with most of this stuff. So we'll do that. Also, in percentage, this number already represents a percentage because it does, right? That 0 to 3, it's 0 to 3%, or 3.1 to 5.9%, and so on. So we hit that. We get, okay, hold on, we'll fix that right there. That's interesting. But you can see it puts that little percent sign in here. Let's go to format labels again, numeric options. There we go. And here we can once again tell it, knock it off. 1 decimal place. Thank you. Okay. And there we go. And so now we have something that actually looks legible, right? You can tell what these numbers mean. And I hit OK. It updates that. Fantastic. So there you go. 2 different ways in which we can take tabular data, meaning data that's stored in a table, and if it has some kind of spatial component, if there's some kind of location, we can bring it in. If it's got some kind of coordinate pair, like latitude and longitude, we can bring that in, do that display XY data functionality. And if it doesn't have that, but it has something that we can join based on, right? So the exact same name in there, like the names of the counties, then we can bring all sorts of data in there and attach it to something that already exists in space. So those are 2 very useful ways to take data, bring it into ArcGIS, and do something with it. Okay, so once you've gotten to this point, hit save. Once you're happy with the way these things look, hit save. Go into your layout view. We have right here. Zoom into an area. Because it's Northern California, with mine I kind of cropped off the bottom a little bit. I also, let's get into our layers data frame properties. With the coordinate system, it defaults to this California teal Albers, which is the standard state of California coordinate system projection. It's what all the official state maps are in. It's also one that's not the most exciting to look at, to be perfectly honest. So I will often close this and go into something like continental, North America. I like some of these Albers coordinate systems. Let's hit apply there. And because it kind of tilts it, I think it just looks sexier that way. Maybe it's just me. But you can do that. Or you can leave it in that teal one. It's up to you. But that's the one I like. So I typically do California maps like this. I just think it looks cool. And like I said, you can kind of zoom in, reposition this stuff. Make sure you have a legend both for your earthquake magnitude, so we can make sense of these graduated symbols, and also a legend for your graduated colors with the counties themselves. And here's a little tip. You don't have to go in here and do insert legend and just have both in here and be satisfied, right? Because we can do this. I'll walk through. I'll even leave that legend title in there because this one's going to be so terrible. So it does this. It's thinking. And there we go. This works. I've got that information in there. Remember too about getting in here and changing these, headings and all of that stuff so it actually makes sense. This change perk might not make any sense. You can just change the whole thing to, percent growth or something like that in here. But if I have it like this, I'm kind of limited in where I can put this stuff. Whereas if I delete that and I do one legend for earthquakes, so I get rid of counties. There we go. Let's just go ahead and do that. And I hit finish. I've got this guy. And I can do a legend here. I'll get rid of earthquakes this time. I'll get rid of this. And then I have a little more freedom. Maybe I want to put one up here and one down here, or want to have them side by side out here in the Pacific. Or maybe I decide after all I want to have them here, right? It doesn't really matter how you want to do it, but the point here is that I have the freedom because I'm not just lumping everything together, right? So don't be afraid to play around with this stuff, experiment with these things. What I would do, frankly, is, save it once you have that basic map, just in case stuff goes too far. You could even do a file and save a copy, right? Like this. This is something I sometimes do. I'll delete that. And I'll call it backup and hit save. And so I'm still not doing stuff with it here. It's still this Quake's working, but in my, that wasn't in here. Yeah, I have my Quakes working and this backup that I can just leave untouched. But if I do screw something up, whatever, I destroy something here, I can just close this, not have to worry about it. I can open up this backup, and in theory, it will look completely normal. It'll be back to that good starting point for me. Let's just open it up, make sure I'm not a liar. Of course, it opens on my other screen. Hold on. If I bring this back over here, you can see it's that original one. So that's a good habit to get into. That way you can play around, you can push yourself, you can see what you can do with this map. And when you're done, whether it's a conservative thing that you go back to like this, or it's something that's a little more bold, a little more exciting to look at, however you do it, hit save, and then do the file, export map, and save it or export it as a PDF, upload it to the appropriate part of Canvas to turn it in, then you're good to go. All right, folks, best of luck.